Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 20th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to both Project Euler and my repository in the description. Let's dive in. Problem 20. Factorial digit sum. In factorial means n times n minus 1, etc. 3, 2, 1. For example, 10 factorial equals 10 times 9, etc. times 3 times 2 times 1 equals this number, and the sum of the digits in the number is 3 plus 6 plus 2, etc., 27. Find the sum of the digits in the number 100 factorial. So this one is honestly going to be pretty quick and easy, because, again, we can kind of use Python to cheat. Let's go ahead and get started. Problem 20.py. Once again, we're going to go back and steal this. Okay, so I'm going to say limit equals 10 to start off with. And then what we're going to do is for n in range, limit 0 minus 1. Realistically, could we have gone the other direction? Yes. It takes a little bit more finagling. I'm just going to call this product equals 1. And then product equals product times n. And, of course, for multiplication, we have to start with a 1, because if we do a 0, it's just going to continue to be 0. So first, I am just going to print the product. And let's go ahead and run this and see if we get the correct answer for 10. That is not the command I meant to run. Okay, so that's the same as their answer for 10. But, of course, we want to do a little bit more than that. Sum equals to 0. String product equals product does that. And then for S in, we just unpack the string product. Maybe I have to use that. Sum plus plus equals int s, and then print sum. And as you can see, I do still want to print out the product, partially just so that I can see it. So I'm leaving that part there. I'm gonna delete this space because it looks weird without doing that. Okay, so obviously we're getting the correct answer for a limit of 10, and we're doing so quite quickly, going up to a limit of 100. That's a very large number, as you can see. And here again, I want to point out, like, Python lets you have numbers this size because it is constricted not by some arbitrary... it's probably not arbitrary, but it's not constricted by a max int value. It's constricted by your memory. So what I want to know is 648. Are you the correct answer? And just real quick, check in. It took like 1,000th of a second approximately to run through that algorithm. So obviously very, very quick. Eventually, as we get higher and higher in our limits, it might not scale quite so well. Like, let's just go up to 1,000,000 and see how quickly it runs for 1,000,000. Computer's working very hard. In the meanwhile, 648 was our answer. And it is correct. So, like I said, pretty quick one. I may have wanted to go smaller than 1,000,000 for the first go. So obviously taking much longer for the much higher limit. But as I've said before, there's no need necessarily to build more than you need, I guess. So, like, our algorithm would not work in other languages, but we're working in Python. It would not work in... it does not scale very well, because that is the nature of any algorithm that has an O of in or n to a power or anything like that. The only thing that would... The only way, really, for any algorithm where you're going through n, even if it's just O of n, not O of n squared, or not, it's still going to get much bigger. The bigger n is, it's going to take longer to run. And we went up by a factor of 10,000. So, that was my cat. It's going to take quite a lot longer to run. Obviously, it's taken already a couple of minutes. I'm not sure how long it will take. I kind of wish I had done 1,000 only first. But I would say that for the given problem, we've definitely solved it. We solved it quickly. We solved it correctly. So... It's pretty interesting to me as somebody who comes from Java, which has a very low limit. Like, you could not represent this number in Java with anything but a string, I think. But for Python, it's like, no big deal. I can have a number this huge. What else am I doing? So let's go ahead and stop this and just do 1,000, because I am not very patient, and I don't want to have a video where we're just sitting here and waiting for the program to run. Okay, so for 1,000, obviously it ran basically instantly. That's 31171. 31174. So it did take technically 3 times as long, as for 100. But obviously still very, very, very quick. I think it is fair to assume that this is the correct answer. But could this solution work in another language? Absolutely not. So, using Python is cheating. And I think that it is excellent. And honestly, I keep calling it cheating. It feels like cheating because of my Java background. The reality is, I am using a tool that is better suited for the problem. And in reality, that is what you want. You want to use the right tool so that you can solve problems quickly and easily. For certain problems, maybe Java is a much better tool. For things like this, obviously Python has a big superiority. But I'm going to call it there for today, and I'll catch you in the next one.